Hey everybody, Bill Sky, the Assembly Guy, and this video is a follow-up of my video on console output. In this video, we're going to do console input. What does it take to actually capture the keystrokes that the user types in? Now, before we get to that though, I did want to talk about one thing. I wanted to talk about where do I get all the information on these application programmer interfaces or APIs for assembly language. Well, believe it or not, it's on the web, but it's very, very difficult to find. So let me actually show you. For Windows, this is the URL. Now I'm putting these URLs in the description of this video, but this is the Windows API index. And there's user interface, Windows environment, user input, and messaging data access. I can click on show more, and you can see all these different options you've got. And let me see if I can find the one on console input and output. Might be this user input. User interaction. I do remember I saw one here just as I was getting this video ready. And here's keyboard input. And keyboard input, they talk about how to do it, the layouts, all this kind of stuff. So this is the way that Microsoft has set things up. How do you actually do the input? What are the values that you put into the registers? And it's all here. And unfortunately, this is just the way it is. For people that are going to be programming, you have to know how to actually get into this. Let me see, keyboard input reference, input functions. Yep, you can see right here. Get key state, all kinds of different things. So you can see how all of these work. And they show them in C and C++, but it's basically the same as it is in assembly language. Now that's for Windows. Now for Linux, I have this URL out there as well, and I like this URL a lot better for Linux. It always seems Linux has easier to read documentation for developers. This is the x86 syscall.sh file, and you can see right here that you've got the number, or right here is the version in EAX. That's the number in EAX you're going to put. So like, let's say on the previous video we did write. We did console write. So there's the 4. That's what you put into EAX. Up here is your argument 0. That goes into EBX. And you put the file descriptor in there. Or you would put like sysout or std out. Sorry, std out. So that's what you would put there. Now if you're going to write something to a file, you would put the file handle in there. Over here, this is the data that you actually want to. This is a pointer to the data that you want to print. And this is the size of that data. That goes into EBX, and the pointer to your data goes into ECX. So you can see where I got that. Also, if you click on x64, you can see the 64-bit ones. So for write, instead of write being 4, it's a 1 on 64. There's your std out or file descriptor out. There's your pointer, and you can see the different registers right here as to how you're going to send things. So that is a nice, that's a really nice reference. Windows, they just do things differently. I don't know why they make it so difficult. It is more complicated. It's not impossible. By no means is it impossible. I've coded in Windows assembly language for years, but it is different. It is a little bit more involved. So take a look at these resources that I put on in the description of this video, and let's do Linux first, and then we'll do Windows. Now we're going to start off, or I'm going to start off with the same programs that I wrote for the console output. So if you haven't seen that video, it might be a good idea to go back and take a look at that video to get up to speed. But we're going to start with the same source code, but we're going to add the console input stuff. So let's get going. So we're on Linux. Let's do that one first, and I'm going to go into the same project that I did on the previous video on console output. It's always a good idea to build upon your code as you do it. And I changed the name to console input output. So I'm going to do the 32-bit first. And let's do a really quick little review of this. We have some constants up here. Now these probably should be fully uppercase, but that's the way I did it. So we've got the constants for 32-bit, we've got our welcome string, we've got our new line, and then we've got the call to our function called write string, which we wrote down here. Now, it's going to work almost exactly the same. But what we're going to do is we're going to write a function called read text or read string, and that is going to allow the user to type in data, and then we'll go ahead and print that. We'll go ahead and print that data on the console after we get the user to type it in. So for read text, you need to do a couple of things. I'm going to say call read string. And we haven't written that function yet, but that's fine. We have to talk about what are the arguments. And what we need to do is we need two things. We need a keyboard buffer. So I'm going to push input buffer. And again, I haven't created that variable yet. And then we have to push the size of the input buffer. And again, I haven't created that. So you push the input buffer, you push the size of the input buffer, and then you call read string. And read string will actually read the data, put it in that input buffer, and then return in EAX the number of characters the user actually typed in. Pretty cool, right? It makes it pretty easy to then go ahead and print that on the screen. So let's go ahead and create our input buffer, and then we can go ahead and start coding our program. Now I'm going to put this in the BSX section. So I'm going to say input buffer, reserve bytes, and let's make it something 128. Let's reserve 128 bytes. And then I'm going to say .length of equals $ minus input buffer. So that's where the user's text is going to go. Now we do have one error in this because we haven't actually defined read string yet, so we're on a good path here. All right, so what I'm going to do is I'm going to copy the write string function. And I'm going to call this read string. Now the reason why I copied the write string function is because it has the stack frames already set up. It actually has a lot of this stuff already set up, so it's going to reduce my coding quite a bit. Okay, so the first thing is going to be is we're going to read. We have the address of this instead of the string to say. Let's say input buffer. So our first argument is going to be the input buffer. The second argument is going to be the input buffer length. And you can see how I push the input buffer, then I push the input buffer length. So the first argument is the furthest away from the EBP. So that's going to be our input buffer, and there's our length of our input buffer. Now I'm going to go ahead and save and build this just to make sure. All right, looks good. All right. But now instead of doing the syswrite, we want to do a thing called sysread. So in EAX, instead of syswrite, I'm going to do sysread. Now let's make sure we have sysread defined. Yep, there it is. It's a 3 hexadecimal. And remember, this is 32-bit. Okay, so we want to read. Where do we want to read it from? We want to read it from standard input, which is the keyboard. And let's make sure I've got standard in defined, and it's 0. All right, good. You can see how copying this code made it pretty simple. And really, that's like it. I believe that's it. Let me check my notes here. So EBX contains the standard in, and so nope. Yep, there it is. EAX will contain the sysread. Very good. The address should go into ECX. That's correct. And the length should go into EDX. I mean, that's it. We actually have that. We've written that function already. So that's pretty cool. So let's go ahead and build that. And now what I'm going to do is, before I print it out, I want to make sure the data is actually out there. So I'm going to debug this. And I'm going to move this little window over there. We're going to have to type into that little window. And we're going to stop right, let's stop right there. The no-op after the input buffer. And then what we're going to do is, after the read string, then what we're going to do is we're going to interrogate that data in the debugger. Okay, so I go back to here. Now, I didn't prompt to have the user typed anything in. It would have been nice if I had printed a little label, please enter your name. But I didn't do that. So I'm just going to say, hello there, I'm Bill. I'm going to press enter. So my debugger stopped at this no-op. Now let's go to memory, and I'm going to put ampersand input buffer. I'm going to right-click on this, and I'm going to say bytes, and there's 4865. Okay, let's right-click on that, and let's do a string. And there it is. So there is the data that I typed in. Now, what does EAX say? So I'm going to go back into registers. EAX says that I entered 22 characters. Now also remember that that 22 characters that I entered also includes the enter key, the new line key. So if I just go ahead and if I print that string, it's going to automatically print the new line key. And that's fine if that's what you want. All right, so let's go back to our code and now let's print it. So I'm going to take this write after I do the input string, and instead of the welcome prompt, I'm going to say write out our inputted string. Is that a word? Okay, so I'm going to push the input buffer. I'm going to push. Now, here's the funny thing, is that if I push the input buffer.length, it's going to print all 128 characters, and I don't want to do that. So what I'm going to do is I'm going to push EAX. And the reason is because EAX returned with the number of characters that I typed in. And then I'm going to call write string. So let's see if that works. There it goes. So it printed my hello there. That's pretty good. Now I mentioned earlier it might be good to have a prompt there. So I'm going to create a new string called input prompt. Please enter some data followed by the enter key. Now believe it or not, you have to tell the user to press the enter key. I've seen users do that before where they just sit there and wait. All right, so there we go. Now let's come down here, and before we do the read string, let's go ahead and prompt the user. And I believe it was input prompt. There we go. And notice that we didn't put an end L at the end because we don't want it to go to the next line. We want to print it in the, or we want to have the user type it right after the prompt. So let's go ahead and see how that works. There it is. Please enter some data followed by the enter key. I'm Bill. And it's great. I could put another prompt saying this is what you typed. So that's console input on 32-bit. It's pretty much the same as the console output. You just have to change some of the numbers that you put into EAX, and I believe it was EDX. Now let's take a look at the 64-bit version. In the 64-bit version, we're going to do the same thing. Here's our standard in, here's our sysread. So let's go ahead and just copy and paste our read string, or write string, and I'm going to change this to read string. And instead of syswrite, I'm going to say sysread. And standard out, I'm going to say std in. And instead of the address of our string, I'm going to say address of the input buffer, the length of the input buffer. So that really, let's build it. Oh, I said standard int. It should be standard in. I mean, look how simple that was. We're cannibalizing our own code. We're getting ready. We've got our constants. It's really nice to do that. Okay, so let's go ahead and create our input buffer. And let's do 128 again. Okay, and now let's go ahead and do it. So I'm going to push input buffer. I'm going to push input buffer.length. I'm going to call input, or I believe it was it read string. I'm going to call read string. Oh, it was length of, right? Length of. Some of you might be wondering, why am I calling it length of? Because that's the same word that Windows uses. So I like to keep things consistent. All right. Now let's go to our 64-bit. And let's make sure this works. We're going to do exactly what we did in 32-bit. I'm going to go ahead and just put a breakpoint on the no-op after the read string, run it. Okay. We can see that RAX received 21 because that's the number of characters I typed in. I'm going to go to memory. I'm going to say ampersand input buffer. Right click on this and say bytes. Right click on this and say strings. And you can see the string that I entered. One thing I want you to notice at the very end here is the \n. That's the enter key. And so we can do the exact same thing that we did on the 32-bit when I printed out the value and also the input prompt. I could do that as well. So it's pretty much exactly the same. Okay, so that's Linux. Now let's take a look at the way you would do this in Windows. Now I actually have the exact same program open that was from the console output video that I did prior to this one. It's no different. Everything is exactly the same. Go ahead and take a look at that if you haven't taken a look at it yet, and you'll understand better how this is working. So what I'm going to do is I'm just going to jump down here, and just like we did in Linux, what I'm going to do is I'm just going to copy the right string proc, and I'm going to rename it read string. And I'm going to save and build it. All right, so it looks like, oh, nope, it said it failed. What was the problem? Right string. Oh, I didn't change the end P, so I have to change that to read string. Some of you may have caught it before I did. If you did, good job. All right, good. So 0 failed. All right. So now what we have to do now, if you didn't watch the Linux version, why did I copy the write string proc to the read string? Because the code is very much it's very much like the write string code. You just have to change some constants that you're using. So, but everything is going to be pretty much the same. So what I'm going to do is I'm going to take a look at this, the size of the string. So this should be the same, EBP plus 8. And I'm going to, instead of the size of the string, I'm going to say size of the input buffer. Okay, and that goes into string length. And, you know, yeah, that goes into string length. We had to get the output handle. Actually, instead of output handle, we now have to get a thing called input handle. And I'm going to show you that value. Instead of write to, we're going to say read from. We have the screen handle, so that's good. Then we have the EBP plus 12. That's the address of our input buffer. And that goes into str address. That's good. And now instead of write console, we're going to say read console. And let's double check this. We have the string address, the string length, the address of the output counter. Now the output counter, what that is the variable that will contain the amount of characters that the user typed in. So Windows just has a different way of doing it than Unix. Now you could change this, because instead of output counter, which is the number of characters that are printed, you might want to create another variable called input counter, but that's up to you. Now I believe we're going to get an error on this because we're not quite done. Oh, it didn't. It took it. Did I save it? I'm amazed at that built. Let's double check it. Okay, it built. So now why am I surprised? Well, I had forgotten that I had put the read console in here already. We have the input handle right here. We have the syswrite. Now we don't have the stdin, and you don't really need stdin because that's part of read console A, so you don't really have to have that. So we're okay. So let's go ahead and call that function. So I'm going to say push input buffer. Now, did I actually create the input buffer? Let's take a look. There's the input handle. Oh, it was called string address. And let's see. So we're going to actually be, oh, see, we don't want to do that. This is the address. What we're doing is this is the address of our actual string that we're outputting to the screen. You don't want to do that. So what I'm going to do is I'm going to create an input buffer. You put the number here that you want to use, but we forgot to define byte. So we want to define byte 128 times, and we want it to be unknown question mark. So let's go ahead and build that and see if that works now. Okay, so we have to say push offset input buffer, and then we have to say push length of input buffer, and then we say call read string. All right, looks good. Now let's see if this works. So I'm going to debug it with start without debugging. And where is it? There it is. Welcome to my program. Hello there. All right, great. Seems to have worked. And just like on Linux, what we can do is we can now print that value. So I'm going to push, and I believe the variable that we put the number of characters in, or that was returned, was output counter. So I'm going to push output counter onto the stack. And actually we have to push the offset of input buffer onto the stack. And then we're going to say call write string. And now let's go ahead and debug it without debugging. Okay. And there, when it went ahead and printed it. So very, very simple. The code is very much like the write string, the read string is very much like that. And the 64-bit isn't much different. Let's go ahead and jump into that. So I'm going to go ahead and recent projects. There's my 64-bit one. And let's do the exact same thing in 64. So I'm just going to copy the write string. We're going to call this one read string. Instead of output handle, we're going to say input handle. And I believe everything is exactly the same. I don't think there's any difference. So that's really all we had to do. Now instead of write console, we want to say, I believe it's read console. And it is. Let's build it. Okay, so we don't have input handle defined yet. So input handle, and we did that in the 32-bit one, but we didn't. Oh, we do, right here, input handle. Did we spell it wrong? Certainly did, spelled it wrong. All right, let's save and build it. Okay, awesome. Now let's go ahead and call it. So we're going to move. Now remember, you can't push an address directly onto the stack. So what you do is you have to put that address into a register, and then you push that register. Now we haven't actually created input buffer yet, so let's go ahead and do that. And it's uninitialized, and let's build it. And let's run it. And it seems to have worked. I got an exit code of 0, but one thing that I didn't do is that I didn't reprint it, or I didn't print it again. So let's go ahead and do that. And let's do an end L. Oh, we don't have to do an end L. Remember, when I press enter, I'm going to also be printing the \n, which is basically the end L in C++. And I'm really glad that I noticed that, because I want to show you how you can eliminate that possibility. All right, that works great. But what if I don't want to print that blank? What if I don't want to go to the next line? Well, what I can do is, instead of well, I probably shouldn't have done that either, length of input buffer. I actually shouldn't have used that because it's printing all 128. I should actually be using output counter. So let's go ahead and do that. Let's use that instead of the input buffer length. Okay, so it printed it. Good. Okay, so the last thing that I wanted to talk about, what if we didn't want it to print all of that? What if we didn't want it to print the \n? So what I can do is I can move into RAX, output counter. I could then decrement RAX, and then instead of pushing the output counter, I can push RAX. Let's see if that makes any difference. It did. So you can see that it didn't print that \n. Now also notice it didn't print the H. I wonder what that's all about. So there actually is nothing wrong with this code. It works great. And I'll show you what I mean by that. I'm going to go ahead and debug this. Start without debugging. And I'm just going to say hello there. But notice the H is missing. Why is the H missing? Is it there? Well, when you debug this, it works differently when you actually debug it. So let's go in here and put a breakpoint right here on this no op. And I'm going to start debugging it. And where's that window? There it is right there. I'm going to type hello world. And notice how it printed it out just fine. So the debugger, the Windows debugger, is doing some strange things here. Not sure what it's doing, but it's doing some strange things. So if you don't debug it, you get that happen. Now I will show you another way of doing this where you don't have to fight with the debugger so much. What I'm going to do is I'm going to right click on the solution and I'm going to say open in terminal. Now what that does is that brings up a PowerShell terminal, but watch what happens as I type commands. Notice how the cursor's jumping around. I'm not sure what's going on with that terminal. So there's actually a much better way of doing this. I'm going to right click on the solution and I'm going to say show open folder in File Explorer. And now from there I'm going to open up x86 debug, and there's my executable right there. So what I want to do is I want to right click on this and I'm going to say show more options, open in terminal. And I'm going to say ./x64 console output.exe. Hello there. Now notice how this works. It didn't even print the hello there without the H. It's the same exact code. This is really weird. And it's definitely a problem that Microsoft has. I wonder if I should open up a bug report on this, because it's definitely a problem. The reason why that's happening is that when the program ends, the output buffer hasn't been flushed. All of the data hasn't been sent to the console yet. And the way that you can force that is that you can print an end L. You can print a new line. So I'm going to just copy that. So right after I write the string, I'm going to do an end L. I'm going to go ahead and build it. I'm not going to debug it from there. I'm going to run it from here. And now everything works good. So you could spend hours trying to figure out what Visual Studio was doing. Its debugger console isn't really, there's a problem there. And also you have to make sure that when you send something to the console, you also want to end it with a 0AH0DH. which in this case I like to call end L, but if we actually come up here and take a look at it, we're sending that along. And what that does is that forces it to clear out that buffer. So that is console input. Now, one thing I do want to mention, if you input numbers, they're still ASCII characters. They're not numeric values that you can actually do math on. You have to convert those. And I'm going to do those in an upcoming video where I show you how to write numbers to the screen. Actually, we're probably going to show you how to read numbers from the keyboard first. You then have to convert those to an actual binary number. And then what you do is you can then do math on it. But also we need to print out that number, that actual decimal number or whatever format that we want to print it out as. So you have to print out that number too, because a binary number, a binary coded decimal number or just a flat hexadecimal binary number in memory won't print because it's not ASCII code. We're going to see that on our next videos.